Question 4, part D, we're asked to calculate the value of W, and we're given some information in this question that we have a different manufacturer this time, produces boxes of cereal that have a mean of 350 grams and a standard deviation of 1.8 grams, and I've represented that here with this normal distribution curve on the bottom left. And we are told that the manufacturer sells all boxes that are above a minimum weight W, and that the probability of this occurring is 97%, or as a decimal 0.97. So to illustrate that on this curve here, I'm not too sure exactly where this is going to be, but I'll predict that it's going to be about here, let's say. So this weight here will be W. We need to find out what this is. But all boxes with weights in this shaded region that I am shading here will be sold to customers. And we know that this probability is 0.97. So we just need to find out what this W is. And the way to do that is to use our graphics calculator. It's the opposite to what we did in part B of this question, if you had watched part B. For this question, we're going to use inverse normal. So let's do those steps now. We go menu, number 5, probability, number 5 again, distributions, and then we're going to choose inverse normal, which is the opposite to normal CDF. So with inverse normal, it's when we have the probability, so we do have that 0.97, and don't have the value on the horizontal axis. We don't have the box weight. So let's choose inverse normal. Now, area. I want to talk about this for a second. This area, if I go back to my normal distribution curve here, is the area of the shaded region. However, there is a really key concept to understand here. The calculator doesn't know whether we are talking about the area to the right or to the left of the value that we're trying to find. It's wondering, hang on, is it this value or is it this value? It doesn't know what you're thinking. So the calculator is programmed to always read the left area. So this one here of the value that we're trying to find. So if this is 0.97, this area here will be 0.03. And you may be wondering, oh, how on earth did you get that? Well, all of these probabilities need to add up to be 1. So in my head, I thought 1 minus 0.97, and that gets 0.03. These two numbers here that I've just underlined need to add up to 1. Okay, so that's a really important concept there, because I see students enter, if you have an area to the right, which we have, I see students enter 0.97, however that's incorrect. It's always the left area. So 0.03, the mean is 350, and the standard deviation is, what was it for this question? 1.8. And that gets 346.615. So 346.615. Okay, so I didn't draw this line exactly correctly. It probably should be closer to here, but that's not to matter. It's in the general ballpark of where it should be. Now, I'm just going to demonstrate my working here. So weight will equal inverse normal 0.03, which is the area, comma mean, comma standard deviation, and that is equal to 346.615 grams. And the question doesn't specify how to leave our answer, so we're going to leave it to 3 significant figures. It'll be 347 grams. And that is the answer to part D, question 4.